We'll begin the conversation of transformations with vertical shifts. So the idea behind the vertical shift is that it is going to allow a graph to be moved either upward or downward. So we have a whole host of parent functions, which are essentially going to be shapes in the Cartesian coordinate plane that we're supposed to be familiar with. So by making small adjustments to the equation for these various shapes, it will allow us to make geometric changes, these are the transformations, within the graph. So we're using the algebraic equation, but it's the way that we interpret it that is this whole transformation idea. So we're really making a connection here between the algebra and the geometry. So the geometry is you're either going to shift up or you're going to shift down. Now the way that this occurs is we have to select a real number. K is going to represent a real number, but K cannot just be any real number. It has to be a real number that is greater than 0. So in other words, K is positive. So we pick K to be a positive real number, and here's what we can do with K. We can take a parent function, so that's what f of x is going to represent. F of x is a parent function, or you might even think of it as a basic shape. And we're going to take whatever the basic shape is or the parent function is, and we're going to adjust it. We're going to make a new version of that. So it tells us here with the first statement that y is equal to f of x plus k. So if I take my basic shape and I add this positive real number, that is going to cause me to shift upward. Now, on the contrary, if I take a very similar equation, y equals f of x minus k. So again, I'm taking that basic shape, but this time I'm going to subtract the real number. And if I do that, that's going to cause me to shift the entire graph downward.